Hi, my name's Amos Sorensen. I'm a postdoc at ANU in Australia, and I'm interested in programming language and correctness of systems. But today I'd like to show off a little demo I've been working on. So I've got this coffee machine here with this raw water reservoir that I need to manually fill up, and I really wanted to plumb it in, but there's no easy way to attach a hose here. I thought that I could attach something like a toilet cistern with a float valve, but I was a bit worried that however I mounted the float valve, it would come unstuck and the hose would come up and it would fall onto the kitchen bench and flood my kitchen. So I was not very confident in my ability to make a mechanical system like that work. So I decided to do it in software so that I could add some extra safety features. So what I've done for that is this is the standard lid. I've printed a separate lid that I can attach my governors to. So here's my 3D printed lid. I'll show you the top first. So the top, I've got this solenoid, which is an electrically controlled tap, really. So the hose here is the mains water hose, and it goes into the solenoid, and the solenoid controls whether the water can flow from the tap. So when you apply 12 volts to this, it opens the tap and water can flow through. That's pretty useful for controlling the flow. And on the bottom here, I've got this float valve, a float switch, which lets us sense the level of the water. So this white ring around it floats, and when it's in water level, it floats up to the top, which opens the switch, turns the switch off. And when it's not in water, it falls down, and that turns the switch on, so that we know that the water level is low. So that's good enough to control the system, but one of the issues is that when this tap is on, it actually pushes a bit of force upwards because the water is flowing out that way. There's some force going that way. So I was worried that if it was seated on the reservoir here, it would push up and get stuck like that maybe. And the water would continue flowing out because the level is stuck not in the water, and maybe it would flood my kitchen out through here. So I wanted to introduce a lever that tells us whether the lid is properly in the reservoir. So this here, I call it the emergency stop switch, but it's really just a lever. So when this goes in the reservoir, it turns off. So we can sense whether this thing is correctly in place. So that's all of the electromechanical, the mechanical stuff to control the system. And now I decided to control it from software because I'm a programming languages software person. So I have a little Raspberry Pi Pico microcontroller here. Here we have the Raspberry Pi Pico, and there's a little bit of extra circuitry to go from the Pico's 3.3 volt logic supply to this, the solenoid, which requires 12 volts and much more current than the Raspberry Pi's power supply can supply. And then we just have some LEDs some indicator lights. So if I package this up, package this not the best 3D, it's not the best case, but it's okay. It's adequate for now. A bit dodgy. So I'll plug this in. This is the solenoid control. Need to plug in. Actually, it doesn't matter how I plug this in, but because it's not polarized. Plug the switches in. This one is. Okay, good. Now I will put some power on. Yes, very good. Now we have a green light, and the green light indicates that the emergency stop lever is in a good state. It's successfully in the reservoir. So if we lift that up, the emergency switch turns off and it's not in, because it's not in the reservoir. So it wasn't turning on, it's not turning on the water right now because the level is high enough. But if we lift it up and manually switch the emergency switch, it lets water through. And it's only a dribble because I've left it low while I'm testing. But so that's nice. Our safeguard for the emergency stop switch works. But I also added another safeguard, which is that, I'll let it run. If it's running for too long, the system turns itself off. It goes into this stuck state. So eventually this is going to go red, and it says, it means no, the tap's been running too long. This shouldn't happen in ordinary operation. So even if we turn the emergency stop switch back on and the level is low, it still won't open the solenoid again. So the only way to get out of this stuck state is to power cycle the microcontroller. Now it's back in a good state. So I think I could have easily implemented this emergency stop lever just electrically with no software control, but for me it wouldn't be easy. I didn't know how to design the circuit for the time limit switch with hardware alone, so it was easier to use software. But also it was an excuse to use a demo for my new programming language project, which is an embedded language in F star called, and my embedded language is called Pipit. Pipit, like the bird. So this embedded language lets you write real-time control systems and verify them correct, and you can automatically prove some simple properties about your machines. For this one, I proved that if the water level is high, then it's never going to run the solenoid. So in this case, it's a very simple property, but in real control systems, like braking controllers in cars, you can have real interesting properties and verify them. So as far as demos go, it's a very simple control system, but I'm happy with how it goes. I can now be confident that I can now leave the house confidently without worrying that I'm going to flood the kitchen. So that's nice.